after some muted microphone to start us going. Welcome again to the Central Water Systems seminar. Hello to everyone in the room, hello to everyone online for real this time. Today we have the pleasure of Matt Brown from Arcadis joining us. He's going to speak to us about sustainable flood resilience at scale, and we're going to be looking at a case study project that Arcadis have worked through. I will pass over shortly. What we'll probably do is have a questions and answers session at the end. So if you can write any questions in chat or raise your hand at the end of the seminar, then we'll work through both in-room and online questions. But yeah, I'll pass over there. Thank you very much, Matt.
Cheers. Could you minimize the panel? Thank you.
Hi everyone, thanks James. Hopefully you can all hear me okay. So yes, as James mentioned, I'm Matt. I'm from Arcadis. Talk through the Mansfield Sustainable Flooding Resilience project that we work on. There we go. So basically what I was going to run through today was a quick overview of what SUDs are. I understand that most people here, or everyone here, knows what they are, so I won't dwell on that. And then get into the case study for the Mansfield Sustainable Flooding Resilience project, which I'll probably just call Mansfield SUDS moving forward. And then some time for questions at the end. Yes, so as I said, I'm Matt. I'm a principal engineer at Arcadis. I've been with Arcadis for 3 years. I'm from Australia, so I studied at the University of Sydney, doing engineering and science, and moved to the UK 6 years ago. And I've sort of just worked through anything civil engineering related to do with water, so dams, reservoirs, SUDs, flood risk management, everything like that. So SUDs, just to skim over, when I went to uni, I was told that SUDs was sustainable urban drainage, which I think was a capital U, and since then it seems to have become a small u, which is sustainable drainage systems or sustainable drainage. Basically, they're aiming to develop a drainage system that mimics nature a bit more compared to grey systems. There's also nature-based solutions or systems that are now becoming a big thing as well, and SUDS kind of fits under that umbrella, but the aim is effectively just to replicate natural processes. Why SUDS? So there's 4 pillars of SUDS that you'll see if you look up pretty much anything to do with SUDS in the UK. Looking to control water quantity, so volumes and flows. Looking to control water quality, so holding water up, improving water quality through filtration and other processes. And then wider benefits of amenity and biodiversity. So that sort of adds on top of what grey drainage infrastructure would typically provide. So that's the driver for SUDS as a sustainable solution to drainage. How the SUDS work? So as I said, they're looking to mimic natural drainage. So considering things like impermeable, reverse permeable surfaces, sort of having the infiltration capacity as well, so the images at the bottom sort of show the difference between what would be a typical grey drainage system with a lot of hard surfaces, not much infiltration or ponding volume, compared to a green system which would have things like interception from trees, ponding areas, drainage, aiming to try and reduce that flow and improving water quality as well. And I think a key thing here, which I was having a discussion with James before, is not necessarily looking at SUDS as the only solution. So considering them as an integrated solution with grey infrastructure as well. So my personal perspective is that SUDS are not like a one-size-fits-all. You're not going to solve all the drainage issues, but it's considering how SUDS and grey infrastructure can work together to give the solutions that people are looking for. These are just a bunch of slides with examples of SUDS, which I'm going to skim through fairly quickly, but we've got all kinds of things here, which are taken sort of out of the SUDS manual. The ones that we were focusing on mainly for our Mansfield sud scheme were swales, rain gardens, and detention basins. And there was some discussion of permeable paving, which was installed towards the start of the project. They kind of fell off towards the end. Yeah, these are some pictures of typical SUDS arrangements for each of those ones listed there. So you can see that they're all aimed to be green, holding water and slowly releasing it back into the system or into the ground. I wanted to touch on flood modelling very quickly. I wasn't planning to go into this in detail, but the point that I wanted to raise regarding flood modelling is that SUDS can be quite difficult to model. Often the modelling information that is done for a catchment is large scale, it's catchment scale, and individual SUDS features tend to be quite small, and so trying to integrate that into a flood model can be difficult, and I think Simon last week was talking about sort of the scale and the distribution of features as well. So my understanding is that typically where we're looking at quite a lot of features, they can generally be sort of pulled together into one volume that's just applied to the point. But there are also ways that we can zoom in and kind of deal with modelling of SUDS at a smaller scale as well. So looking at sort of a single road and things like that, but then it's sort of integrating a lot of different models. So we worked with infra drainage for the Mansfield scheme, where we were dealing with quite large SUDS features, but then the smaller features we were doing with Excel calculation sheets and things like that. And the aim overall for the Mansfield project was to have a model of the entire area and integrate all of those features in. Unfortunately, we weren't involved with that, so I'm not quite sure where that ended up, but they had quite a lot of large features and detention basins as well that they were including in the overall model, but then trying to work out how to integrate these drainage models and smaller features to capture the volumes that were provided across the catchment. So it can be a challenging issue to look at for a catchment scale in terms of understanding the benefits and the overall modelling of these features. So, the case study for Mansfield. The project was a catchment-wide SUDS project that was led by Severn Trent Water. They worked quite closely with Nottinghamshire County Council and Mansfield District Council, so that they were the owners effectively of the highway land and the local borough or local council where the SUDS features were to be deployed. The aim initially was to deliver £76 million worth of flooding resilience through nature-based solutions, typically SUDS and detention basins. I understand that increased at the end to around £100 million. And the overall aim was to deliver this catchment-wide approach that I mentioned. So you hear me talk about at-scale delivery and also at-pace delivery. So they wanted to get this delivered within one end cycle. So they effectively delivered start to finish in 5 years. And the initial aim, they were talking about 15,000 features. It was quite a lot less than that in the end, which I'll touch on in terms of some of the challenges. And they were looking at originally about 80,000 cubic metres of water retained through these features. Again, that was a little bit less than what they'd anticipated from the original business case. Mansfield was chosen because it was identified as one of the most vulnerable areas at risk of CSO flooding within the Severn Trent Water catchment, and they projected, so their modelling was projected the flooding to increase quite substantially by 2050. So the aim of the project was to provide some resilience to that, and they also had the River Long that runs through town, which had some water framework directed outcomes that they were targeting in addition to just providing some of the flood resilience to town. You'll see on the left there are quite a few different parties involved, so Severn Trent sort of were leading overall. We had multiple contractors, multiple designers involved with this to try and get everything delivered quickly and make everything work. So this is a bit of a zoom in of where the locations for the SUDS delivery were. So all the red dots are effectively a SUDS feature across town. The way that they split up the work was, if you imagine a line running sort of northwest to southeast. The northeastern catchment was delivered by one contractor and their set of designers, and the southwestern catchment was delivered by a separate contractor and their designers. So at Arcadis, we were working with the southwest here, with a contractor there, delivering features in that area. Like I was saying, there ended up being sort of 300 to 350 features built, and they ended up in the order of 31,000 cubic meters of storage across the catchment. The initial designs they looked at, so the outline designs that were developed, there were, I think, 2,000 designs, just at a very high level to say these are areas where we think SUDS could be developed. And yeah, there was quite a process to go through those and work out which ones were sort of the most cost beneficial to proceed with. And like I said, there's this delivery at scale and delivery at pace, which is the two key things that Severn Trent Water were looking to do. So the delivery itself, it worked through the previous AMP cycle. So the original business case was developed in 2020. It was approved, I believe, somewhere in 2021, 2022. And there were some key steps I've tried to put out here, which I think was sort of important in the overall success of the project. So one of the key things was developing a sort of set of standards for SUDS delivery in this area. So basically having, there were two documents effectively. One was the highways design guide, so talking about what considerations need to be made in the highway for when we're looking at permeable paving, where they could be installed, what the risks are, dealing with bus routes, dealing with widths of roads, things like that. So getting into the real technical detail of where SUDS could be placed and what constraints there were. And then there were also standard designs that were developed at the early stages to identify sort of what materials could be used, what Severn Trent Water, what Mansfield District Council, Nottinghamshire County Council would be happy to have in their land. So developing these sort of guidelines, I think, was really key in sort of setting a process that all the different designs and contractors could get on board with. And I'll touch on this a bit later, but the other key thing to this was also just having them continually updated. So it wasn't that we set all these processes in 2021. It was that we'd started having these set up, and then as different parties got on board, we still worked through the challenges and updated those to make sure that things were sort of up to spec. 2022 to 2023 was where the concept designs started. So you'll see down the bottom left, that was a typical concept design. So it was an area in the catchment with an indication of what features there could be. So in this case, it was a bias swale in the green space and then permeable paving in the road, and they would work together. And what Severn Trent were really keen on was getting an understanding of the catchment that was disconnected by those features and the volume of storage, and that sort of fed back into their business case to get the funding. So, like I said before, there were about 2,000, I understand, of these concept designs developed by AECOM and ARIC across the whole of Mansfield, and then the next stage, so sort of 2023, was when they started getting the contractors involved, and that was done through a design and build agreement. So the contractors got involved, and then they brought in a whole bunch of designers to deliver everything through, from concept through to construction. So we were brought on as part of that, and then effectively reviewing each of the sites, working out what was feasible, discussing those, and then developing them through to construction stage. So the image at the top is an example of the same site. At the bottom there, developed for construction issue. So you'll notice the permeable paving fell off the radar. There were some issues with that, which I'll discuss a bit later as well. But sort of getting into a bit more of the detail, you can kind of see how the shape of the features and things like that changed based on the site information that we had, which I'll also talk through a bit more later. And then 2024, 2025 was when there was a big push. I think there there were some 7 or 8 design houses and the 2 contractors involved to really push all these designs through and get everything built by the end of the end period last year. So I think it was sort of April, May that they were looking to finish everything off. So that's the overall process that was followed. Getting into some of the detail about what the design involvement was. So all of the features, it was decided to be designed for a 1 in 10 year 4-hour storm, so more a volume of storage than a flow, like a runoff. So that was for 35mm rainfall depth. As part of the initial works, Severn Trent developed a spreadsheet calculation tool. So these are some snips for that, which was effectively looking at different layers of the suds features, how much water was stored in there, and then working out from there what size, so given a certain orifice size, how much water would slowly return back into the drainage system, how much would be stored there, and they would use that as their business case. So the 2 blue circled, squared numbers down the bottom, they were the key numbers that Severn Trent were after. So the first one, 11.11, that was the network storage volume of the suds feature. So that sort of fed back into their business case. And then they were also looking at the half drain downtime to make sure the suds features were effective in sort of consecutive storms. So for the rain gardens and rain gardens, they were looking at a 12-hour, 48-hour drain downtime, and then for the larger features, they were at 24-hour half drain downtime. And so we had to sort of modify the orifice size to suit for that. So the design spreadsheet was fairly well set up in terms of what inputs Severn Trent wanted and what outputs they wanted to get. We did have to work through some examples. The way it was set up didn't suit all features, so particularly when we got to quite complex geometries, we had to work through amongst all the designers to get a process for how to fill out these sheets and make sure that they were filled out correctly. So in terms of getting the volumes and the storage calculations right. And this was particularly tricky where we had sort of underground storages as well. The spreadsheet set up initially was fairly straightforward, but it was sort of a continuous process to update how it would work and get the outputs that Severn Trent wanted. That was sort of the process that we followed for most of the suds in terms of the calculations. So working through spreadsheets, doing checks to see how the volumes matched with what we would typically do. But there were features that we also did sewer diversions. So, sorry, I should take a step back. Most of the features that we were looking at were taking surface runoff into the feature. So we weren't diverting sewers or anything like that. They were running either directly from carriageways into the suds feature or from a gully into the suds feature. So that was the typical arrangement of the suds that we were looking at. In some cases, and the reason for that was a lot of the sewers were combined sewers, so we couldn't divert the combined sewers into the open suds features. So we focused on the surface water drainage to capture it before it got into the sewer and became contaminated effectively. There were some locations where there were separate sewers, separate surface and foul water sewers, and in those areas we were able to assess whether we could convert the sewers into the feature as well, and so that gave us a much bigger opportunity for disconnecting volumes. They were done completely separately. They were the features that we had to do through input drainage to understand the design and the volume storage. We still needed to plug it back into the spreadsheet to get the volumes, but the designs were done probably as we would typically do them. For those examples, we also had to do testing of the combined sewer, the surface water sewer to make sure there weren't any misconnections and that we weren't diverting dirty water into our open features. But yeah, aside from that, it was sort of the safe bit on the larger scale. So getting into some lessons learned for our delivery. So the first, I've got 4. The first one is the standardization that I mentioned before. So having these details, having the guidance document requirements there from the start that different design houses and different contractors could pick up. They would understand what materials they needed to source, they understand what the maintenance requirements were, they knew what the councils were happy to work with, and it helped pick up, it helped everyone to pick up the designs quite quickly. Everyone understood the process, they knew what the outputs were. And I think without that, we wouldn't really have been able to get things done as quickly and efficiently and within the time scales that the client was after. So that was the first one. The second one is the site constraints. And this was sort of the process of going from the concept design to the detailed design. We found that with more information, it became increasingly harder to deliver the studs. So the more we knew about the site, how steep it was, where the utilities were, infiltration, capacity, things like that, everything, not everything, but a lot of things seemed to work against what we would want to do. So we started off with this huge amount of sites. I think as Arcadis, we looked at 50 to 60, and we only built 25 to 30 of them. So half of the sites were basically ruled out for one reason or another. So there were things like high pressure gas, high voltage electrical. Client didn't want to deal with that at all. Too high risk to work around, it cost them too much. So any sites with that information nearby was immediately scrapped. The example at the top there with all the utilities through the feature, there were sites like that where it wasn't cost efficient for the client to deliver those compared to others, so they made decisions to scrap a lot of these sites where they were quite congested with utilities. Going off on a bit of a tangent, there's I've had discussions for other pieces of work around utilities and things like that, and it's a big question that comes up quite a lot, not necessarily in terms of construction, but in terms of maintenance of these features. So if the utility companies need to get in, do work to their services, how do they reinstate the subs features? It's not a typical, it's not like highways design where you've got a guidance to say this is how you reinstate carriageway. They don't have a typical sort of SUDS reinstatement design at the moment, so contractors are a bit wary of taking on these kind of features where they've got utilities running through. So to me, that's quite a big challenge for SUDS moving forward, particularly in areas like urban areas where you've got a lot of utilities that need to be worked around. But yeah, so working through this process, we ended up losing quite a few features, and it wasn't that they necessarily weren't buildable, but it was just they weren't cost effective for the client as well. So working out how to kind of identify these constraints early doors and making decisions earlier about which sites are suitable for SUDS, which ones may not be, is quite a useful thing to do. Towards the end of the project, we were sort of getting a bit more familiar with what maximum rates we could work with, what utilities we could deal with, and the conversations became quite quick in terms of whether things were buildable or not. But it takes time to work through that, and they can be quite site specific as well. The third one, lesson learned, is about stakeholder perception. And I guess at a large scale, I think the thing that stuck out to me most was how varied stakeholder perception can be. Usually when you're sort of dealing with an individual site or something like that, drainage basin, you're looking at quite a localized area around that feature. But in this case, because we were working across the whole town, you had sort of the localized area where the SUDs were being built. But because there were so many, you often had quite a lot of road closures around town. So people, like residents that weren't in the vicinity of the actual SUDS construction, were getting quite frustrated with where they could drive through town, things like that. So it was kind of this large-scale perception or impact on stakeholders, as well as the local scale where the SUDs were being built, which was quite interesting. There were some challenges with stakeholders throughout the project. So we started off looking at a range of different features, sort of in carriageway, in verges, in green spaces, And due to the feedback that we had from the community about disruptions to parking, buildings within their verges, and then sort of general works around town, the decision was made to remove all of the features that were in the carriageway, so all the street rain gardens, all the permeable paving that was built in the carriageway was scrapped overnight due to discussions between the client and the community, and so we ended up working, like in these pictures here, it was just purely in green spaces nearby. So that was one of the biggest impacts of stakeholder involvement in this. The other interesting thing that I found interesting about stakeholder engagement was we had one site of ours, which I've got a picture of later on. It was quite a big bioswale, effectively like a detention basin in a green space with a nearby community. And the community was very against building in this green space, but they had a track record of flooding in this area. It was at the bottom of the hill, and they had quite a lot of water running down the hill and into particularly 2 or 3 people's properties down the bottom. When they were trying to work through building this feature, they had a community engagement event, and from what I've been told, they sort of explained what the works were. The community were very against it, but then one of the guys, I think it was a male, at the bottom of the hill who had experienced the flooding, stood up at the event and basically explained to them, you know, I basically get flooding in my house every time it rains because the sewer's surcharging. This is going to help my house from not flooding. And as soon as they talked about that, everyone else in the room sort of got on board, and that feature ended up going ahead. So I think it's sort of, to me, it demonstrated the power of knowing the right people to kind of work with from the community to sort of explain the benefits of what the sites can bring as well. And the last one is about construction, particularly sort of this retrofit sites construction. The main point I wanted to raise for this one was that it's not easy to build these. They can be quite sensitive to changes because we're trying to fit them in spaces that have quite a lot of constraints, that we're working with existing levels. We don't necessarily have the opportunity to kind of change catchments to make sure water's getting into the feature. So the top image, for example, we had very limited fall to get into the feature where the curve is, and if that was raised like just within the margin of error on site by the contractor by sort of 25, 30 mil, it would mean that the whole feature becomes ineffective because the water's diverted past the feature. So it's sort of being conscious as a designer, my perspective, of what tolerances and margin of error the contractors need to work with, and I think it's sort of the other way around as well, the contractor being aware of what is sensitive in the design, so what they really need to get right to make sure the features work as designed. So it's not easy. I think it's particularly challenging where these are sort of quite new concepts to a lot of contractors as well, and making sure things are done right with the right materials. It is difficult, and something to be aware of when delivering these schemes. I think the other thing was supposed to be on the last slide, but with the stakeholders and community involved, the other challenge that we had was once the SUDs were built, they were left sort of open, so like in that top image there, they're kind of left open, and you can see that there's tire tracks and things like that as well. So there were some challenges with materials being stolen. So people were taking stones out of gaping cages, taking turf from site, so they'd see all this nice turf around and pinch that. So there were some challenges with dealing with sort of the community in that regard as well. So there were some sites that they had to fence off after they were built to allow everything to establish and not disappear. So some things you think of. some you don't. So these were just some pictures of some of the sites. This is sort of the end of my spiel. So this was just an illustration of how they can come together. So the top left is what was there previously, an example of the construction, and then what it looks like now. So a lot of them look quite similar, but these were sort of the spaces that we ended up working in. So this was one of the sewer diversion areas. So there was a sewer in the road kind of towards Screen that we were able to divert into this SUDS feature. So this was all modelled in drainage to understand how ground basically work in a big storm or an exceptional storm. So these were all designed with a diversion chamber in the road. So the water would come into the diversion chamber. There was an internal weir that would divert the water into the feature, and once the SUDS had filled up with water, it would back up into the diversion chamber, go for a weir, and then continue down the sewer as normal. So that was sort of the agreed approach that we worked through with Seven Transporter. This was the large feature that required a bit more community consultation. So I think this was about 200 cubic meters. I'm getting that right. So you can see in the bottom right there, that's one of my colleagues at the end. So the basin itself was getting on a meter and a half deep. But some of these features were, they're called SUDS, I guess, but they're urging for on detention ponds. So, yeah. And these were just some other images from the work. So there was a special turf that was used. So the second image, the top left, so it was a low nutrient turf, which basically didn't then allow for prolific weed growth. They got it wrong on one site, and after a week it was just meter-high weeds all through the feature. So it was details like that that were quite important to get right. So these are sort of things that were specified in the client documents. They were sort of working through with everyone throughout the design. The third one in is a street rain garden, so it's built out into the road itself. Like I mentioned, they were canned after a little while, but they built quite a few of these features. So street rain gardens, by paving different parts of town, and then sort of moved away from those. Yeah, these are just some other sites. So typical sort of build up and planting of what they were. Most of the features sort of took drainage directly from the road. So this example is the second photo in from the top left there is a beanie curve. So there were a few of those areas where we had a bit more extensive drainage that was put in purely to prevent the width of flow in the road from becoming too substantial. So in this case, we only had two gullies that were spaced quite a way apart, and we wanted to remove them. We wanted to remove the top one to maximise the catchment coming in, but it would have meant the flow in the road was a metre and a half. So we had to end up putting this beanie curve through there to take the water off the road rather than letting it flow down into our SUDS feature. Yeah, this was just a summary. Hopefully I wasn't too long or too short, but effectively what the project was able to do was show that we can deliver a catchment-wide SUDS program. We can deliver it quickly, but it is important to have the processes in place to allow for that. It's not just sort of a pick up and run. It takes quite a lot of planning and quite a lot of involvement and iterative work as well. The standards that were developed and the drawings that were developed, it wasn't just this is what you're working with. It was here's what we're proposing. If there's issues, let's discuss them. Let's work through the details and revise them as we go. So I think it's sort of being open to those discussions, working through with everyone, and being adaptable for that. Yeah, I think the other key takeaway is probably understanding better how what's achievable, I guess, in some ways. So when the project set off, it had quite maybe optimistic targets, I guess, but then working through getting into the detail of delivery, it's probably not quite as straightforward as it may seem. So going from sort of the concept design to detailed design, working out what's cost efficient, things like that, it can mean quite a lot of changes through the process as well. But it doesn't mean it doesn't work, but I guess it's just being realistic about what's achievable and the volumes and the scale that can be applied at. And I think, yeah, that was it. There's some things there that keep on that. Good, yeah, cool.
Okay, so we've got a bit of time for Q&A. Is there any questions from the room to start us off? Sure.
Hello, thanks for sharing. And I was working as a landscape architect, and so this is a very good example to show how the project development from the conceptual to construction case. And my question is, as from the hydrological perspective, and on the conceptual design phase, the national surface flood risk map I used as initial screening tool to identify the potential area for intervention. While the risk map only shows the inundation risk on the local area, but the water could or even could come from other else areas. So in this project, how to identify the priority intervention areas? Yeah, that's my question.
Yeah, so I think this project was probably fairly unique in terms of how the areas were identified. So the risk of flooding maps, I think, were used initially for the initial business case and the Southern Track water put in. They also did their own studies to understand where the most area, like the areas were most at risk of CSO spills and things like that. I think doing the catchment scale, they weren't necessarily, and this is one of the challenges that they had with stakeholders as well. The locations weren't necessarily where the flooding was occurring, so it wasn't like the hotspots in the risk of flooding from surface water maps or the outputs from that. Because they were taking a larger approach, they were just looking at any areas within the town, basically, where they could put these features in, understanding that the entire catchment was contributing to flooding in certain locations. So one of the challenges they had was that people were often coming out to see the works, and they would say, we've never ever had flooding here. We're on a hill, we're halfway up the catchment. It's not an issue for us. Why are you doing works here? And so it was helping them to understand that even though they don't experience flooding, it's the people downstream. So it wasn't. It was a bit of a mix between working out where the flooding was occurring and targeting that, and also just looking at the town overall and knowing that the sewer overflows, the sewer network was connected to 2 treatment plants, and so it was basically any sewer within the area would contribute to that, if that answers the question. Like it wasn't specifically about risk of surface water flooding. It was kind of targeting any areas that would contribute to it. And I think that's different. So when we would typically look at SUDS or design SUDS, we would do exactly like you say, we look at the risk of flooding, see where the source of that water is, and target those. This was a bit more large scale, so it wasn't specifically looking at the hotspots.
Hi, thank you for your time and presentation. I have one question about uncertainty. Nowadays, many researchers focused on using SUDs, different types of SUD, but in my opinion, most of them not pay attention to uncertainty. and I want to know that is it have a, or does it have a one main reason that they prevent to study about uncertainty or not?
In terms of where things were deployed, like what sort of uncertain?
About, for example, analyzing the SATs with the main and the original form, like calibration.
Yeah.
Yes, I want to know about that.
And I guess in terms of like modelling, you're thinking of like overall.
Yes.
Yeah. So I don't know the details of the modelling for this. I know that they had set up a model for the catchment, so they had like a pre-works model, and then they were developing the model throughout, adding in the features as they went. So I'm not sure how they added in each individual feature and what kind of thought process went into that. I don't know what uncertainty they considered in there. I don't know, sorry. But I know that they were looking at, so there was a piece of work to basically take the modelling work that was done previously, like before the scheme, compare that to the model with the features in there, and that was going to be their baseline difference. And my assumption is that they would then try and compare that with the spreadsheet outcomes and see how they worked between the two, and whether the volume that they predicted to be taken from the sewers is actually happening, and whether the properties protected are there. But the details of the modelling, I don't know, sorry.
Yeah, great to see such a large-scale rollout. I wonder if, or are there any plans for future monitoring to sort of see what the impact actually is in reality and see if it sort of lives up to design expectations?
That's a good question. I asked the same question as well. I understand that they were putting in monitors in a lot of the outlet chambers, so each of the features had a flow control chamber with the orifice plate, and I understand that they were going to put monitoring data in there to understand the response to storms. I think it was being done in collaboration with Sheffield Uni, so they were involved with some of the work with this. I haven't seen any outputs, so I don't know whether it's gone ahead or not, but that was the intent, was with all these features, being able to have nodes where they can understand how the sewers are basically responding to the sludge in there. So I am hoping there is some more information on that soon as well, because I think it's important to understand how this is going to affect everything and whether they actually work, which is a key thing.
Thanks for your presentation. I was wanting to ask you about the maintenance plans for implemented SATs. Do your team have any plans? Because it seems that their effectiveness will be affected by the passing of the time.
Yeah, so all the maintenance was taken on by Severn Trent Water, so they had, as part of the project, they've got a budget for carrying all that out. So that was one of the, I think, probably the sweeteners for the local councils. A lot of the land they owned and would have to maintain is now effectively getting handed over to Severn Trent Water. And that was one of the key things for the development of the details and things like that. So understanding how the makeup of the subs is there, what's required to make sure they continue functioning. I think it goes back to the maintenance as well, having the having monitoring in place to understand which features are working, which ones aren't, whether remedial work is being done. So that was all taken on board by the water company. So I think that's, my understanding is probably quite unusual, these type of features. A lot of them are taking it directly from highways runoff, so probably be typically a highways feature, but these are all agreed to be taken on board by the water company.
Can I just check if we have any questions online, please, Albert?
No.
Okay, if you are online and you'd like to raise any questions, just raise your hand and Albert will let us know. Any other questions in the room?
Yes, thanks for your presentation. And I'm wondering, have you any considered any biodiversity index when you assess this project?
The short answer is no. So, but I think it's to do with how quickly things roll down. So there will be biodiversity net gain. I don't know how that's been calculated or assessed. It wasn't part of the design criteria or anything like that. I don't know if Severn Trent had their own separate system where they were looking at like what the overall benefits were, or effectively for the design what we were tasked with was the storage volume. So we were kind of focusing on providing the storage to take the water from the sewers. We also looked at things like water quality and making sure that the suds were effective, but we weren't calculating that for Severn Trent. So their key outcome was the storage volume.
I see. Maybe I will just check their website to see if I have
Yeah, if there's something there. I'm not aware. I imagine there would be some criteria for what they had to achieve, but I wasn't made aware of any requirements for that, so we didn't have to do any of the BNG calculators or anything. It was purely to do with volume and delivery. So I think that I'm going to use the words, but it was sort of put out as a pilot scheme to work out whether this kind of project was deliverable, like at this catchment scale and at the sort of speed they needed to do it. So the primary test was, is this achievable and can it be, I guess, replicated or rolled out in other places? But there are a lot of other benefits and questions that probably got skimmed over as a result.
And I'm just thinking if you sometimes if you negotiate with the local residents, if you show there some biodiversity benefits, maybe they are more willing to accept this project.
I agree. Yeah, and I think with the community and stakeholders in particular, I think getting them on board quite early is really important. If they can kind of see an ownership of the scheme, it seems to have quite a big impact on the way that they perceive it. So, like other schemes that we've worked on, sort of going and talking to the community and explaining to them, we're going to build a rain garden here. It's going to be effectively a sort of flower bed or a nice sort of space for them. It's amazing how many community members are almost happy to get involved with planting, like maintenance and things like that. So making sure things are looked after, like they sort of see their sort of area as their space, and they want it to be really nice as well. And I think that's probably, again, it wasn't, I guess, the focus of this work, but it's something that I think is an important takeaway is working through the community engagement and stakeholder involvement, because they can have a massive impact on what's viable.
Online?
Yes, thank you. Very, very nice talk. I'm wondering, this is mainly designed for the flood resilience.
Yeah.
But in your opinion, on the opposite side of the flood, how this will help in terms of drought, or could this be affected by drought?
Yes, it's a good question. I don't know that there would be any it probably depends on sort of prolonged drought.
Yeah.
Like obviously the features, if it is prolonged drought, then they're not going to look as nice. Like a lot of the greenery is going to disappear. They are designed so that, most of them are designed so that as soon as there's some rainfall, the water will get in there. So even if it's not a lot, like to cause a flow in the sewer or anything like that, they are the first point where the water will come in. How they would perform, I'd like to think there wasn't a big hydraulic difference. A lot of the outlet chambers were protected, so even if they were dry for a long period of time, the way that the outlets were set up was they had the outlet chamber with the orifice on the upstream side and a perforated pipe coming into the system, which was wrapped in fabric. So assuming everything's working correctly, that chamber should be protected from any silt or debris and things like that. So I think it would probably be the appearance and things that would be mostly affected, and the hydraulics once, I mean, it depends on how the material compacts and stuff like that, but yeah, once it gets a bit more rainfall again, I don't know if there would be any change. I don't know if that makes sense. I don't know what the basis was for that.
It's main purpose, but
No,
just curious.
I don't think it would be a disbenefit in drought, but I don't know that it would. Yeah. To be honest with you, I haven't really thought about performance in drought. The materials and things like that were designed to be fairly open, so I'd like to think that they didn't quite compact and become inefficient over a drought period. So the materials that we used shouldn't become like it wasn't like a clay or anything like that that would become quite impermeable during the drought period. So it was a mix of sort of organic material and sand and things like that, which should remain a bit more open even after the long drought.
Thank you.
Okay, I think we've got time for one last question. So,
Okay,
click on the draw there, so you get it.
Thank you. So I'm wondering about the permeable pavement to your soil. So what is applied in this project, or how is generally applied, adopted in the UK?
Yeah, I think permeable paving is quite tricky. Personally, I haven't worked with it a lot. It seems to have, I hesitate to say, but more challenges potentially than benefits. So it was deployed in this scheme. There are areas where they put permeable paving in, and it was particularly in sort of curbside parking. The challenges that they had was that the area that it can be deployed, or they were happy to deploy it, was quite constrained. So they didn't want it in sort of bus routes or heavy vehicle routes because it would get damaged quite easily. They didn't want it in areas of heavy turning, so cul-de-sacs, intersections, things like that, because the turning movement of the vehicles can destroy the pavement as well. And they also had a setback from intersections and turning points for the permeable paving because it doesn't have as much skid resistance. So if people come up to an intersection and go to brake hard, then it doesn't provide as much, like the stopping distance is a lot further. So they had quite a lot of parameters to work the permeable paving around. And then what they also found is that the areas where they deployed it, because of the fall of the road, because of the crossfall, by the time the water was reaching permeable paving, it was concentrated along the curb. So the width of the permeable paving itself wasn't actually that effective. It was coming in sort of in the first meter there. And if that wasn't working well, it got blocked quite quickly, the water would just run along the curb and bypass the paving as well. So there were quite a lot of challenges to get the permeable paving to work. It was taken out of the scheme when there were the challenges with closing the roads and things like that. So we had some designs where we used permeable paving, but they weren't constructed. But it is I think it's probably one of the more challenging SUDS features to deploy. I know there's a lot of different technologies in terms of pavers and permeable asphalt and things like that. I think each of them have quite a few challenges with maintenance and how they react to water. One of the other things that they found with the permeable paving is if you've got quite a lot of debris being brought down in the surface water flows along the curb, as soon as that hits the permeable paving, the water drops into the paving, but the debris obviously sits on top, so you get quite an area of clustered debris across the road where the permeable paving starts. Not that I'm against permeable paving, but it definitely doesn't seem like the easiest thing to deploy. And the other challenge that I've found with permeable paving is getting councils to, particularly the highway side, to take on board the maintenance, but also how permeable paving reacts under load. So it's the same with soakways. I've worked with some councils who don't want soakways in the road because it's putting a lot of water into that spot, and that causes the ground to consolidate in that area as well. So it's challenging. It it was used. There were some interesting outcomes, but it didn't perhaps perform as expected. But I think it's something that's quite interesting and would be good to understand where to deploy in the future, where things would work.
Okay, can we have another round of applause for Matt, please? Do you know the details of next week's?
In 2 weeks' time?
2 weeks' time?
Yeah.
Do you know what the
25th.
title is, or?
Got to check.
No worries.
I'll circulate. No
Okay,
worries.
so our next presentation for those online, 2 weeks' time, and we'll circulate details of that. But thanks very much, Matt. Have a lovely week, everybody. It's been a long week already. Thanks, guys.
Thank you.